Thanks for joining us. Today we were going to talk about what we have been working on for like the 18 months ago. We're going to share what we are working on, like security, discovery, integrations, and JobSink, and also event transform. I'm Pierangelo, and I'm a software engineer at Red Hat. I also have be the working group lead in eventing, and here's Christoph.
Hello and welcome from my side as well. My name is Christoph. I'm also working at Red Hat as a software engineer on serverless topics, and I'm also a maintainer of different Knative Eventing projects. So let's see what we have on agenda for today and what we'll show you. First, we'll give you a quick update on the latest eventing security features, including support for transport encryption and authorization. Afterwards, we show the latest updates on eventing integrations, how you, for example, can connect to third-party services like AWS SQS now, natively with eventing. Afterwards, Pierangelo will give us an update and introduction on event discovery and the new JobSink feature. And finally, we'll give you an overview about the brand new event transform, which helps you to kind of reshape your events, and which is an often asked feature from your side. Okay, let's first start with security in Knative Eventing now. By default, Knative Eventing does not enforce security on event delivery, meaning traffic is unencrypted, unauthorized, and unauthenticated. And we all know this poses risks in not only production environments, and enterprises need secure event-driven architectures. And to address those needs, Knative Eventing provided in its latest or recent versions 3 new key security features. And those are transport encryption via TLS through HTTP endpoints to make sure event traffic is encrypted. Then authentication via OpenID Connect to allow event consumers to verify who sent an event. And finally, authorization via event policies, which plays together with authentication to allow you to restrict who can send events to your resources. Okay, let's start with transport encryption. As said, by default, Knative Eventing does not enforce security or does not encrypt events. And we all know that as soon as somebody has access to the network, they could potentially intercept those events, and this poses risks. And by providing HTTPS endpoints for addressables, we now can, or addressables now accept TLS encrypted events. And this is done on 2 sides. First, addressables provide their HTTPS endpoints, or provide an HTTPS endpoint. And depending on the transport encryption feature flag configuration, they provide only an HTTPS endpoint when the configuration is set to strict. If the transport encryption mode is set to permissive, they provide an HTTP and an HTTPS endpoint, or both. And when it's disabled, of course, then we fall back to the current behavior, what is providing only an HTTP endpoint. And event producers, on the other hand, they prefer sending events to the HTTPS endpoint. And for the certificate generation for the HTTPS endpoints, we use Cluster Manager under the hood, so no service mesh or anything else is needed from your side. On the resource side, this looks the following. Here on an example on a broker and addressable, we have now the status addresses fields. Maybe you know from before we had only the status address fields, but since we now can have at least 2 addresses, the HTTP and the HTTPS one, in case it's permissive. It's now simply the plural form. And there we have the HTTPS address with the certificate and the HTTP address. Okay, so TLS helps us on encrypting the events. But what happens if you want to kind of protect your broker that not everybody can send events to it? So, for example, define some access rules or some policies and protect your broker that only source XYZ can send events to it. Therefore, we need first authentication to verify where the request comes from or who sent it. And finally, authorization to implement the policies. And for authentication, as said, it helps us to verify who sent the request. And therefore, we are using or integrated OpenID Connect to help us or to ensure that we can verify who sent the request. And this is also done on two sides. First, the addressables, they provide the so-called OIDC audience in the status. This is an auto-generated unique field, and it will be automatically pre-populated for you when the OIDC authentication feature is enabled. Event producers, on the other hand, they also create a service account under the hood for you, also automatically. And this new service account serves as their identity when sending events. So when the event producer now sends a request or wants to send an event, it requests a new OIDC token for their identity service account and for the audience of the target, and attaches it to the request in the header. And then the addressable, on the other hand, when it receives a request, then it checks the authorization header or the token. When it's okay, it passes it through and continues with the event processing. When it's not okay, for example, because the token expired or because it was for the wrong audience, then it declines it by a 4-1. On the resource side, it looks the following, that on the source side, on the event centers, we now have the identity of the service account provided in the status auth service account name field. And for the addressables, as they have the audience, this is also automatically populated for you. It is the status address audience field. And it's, of course, also in the addresses field, as we saw on the TLS slides, but for simplicity, we have it here. Okay. Sorry. Yes. Okay, so now we know who sent a request, but with authorization, we can now, or authorization should help us to restrict who can send events to your resources. And we do this by, as we added a new custom resource called event policy, and in this event policy, you can specify who can send events to whom. And the event policy has two main fields. First, the spec.to, where you can specify which resources are going to be protected. For example, you can do this by providing a direct reference, as in this case to a broker, or you can also do this by a selector, by selecting multiple resources which are kind of protected by this event policy. Also, as a side note, when the spec.to is empty, then the event policy applies to all resources in the namespace. And the other important section is the spec.from section, where you specify who is allowed to send events to the above resources. And you can also do this by specifying a direct reference, as we do here for ping source. And this can also be come from another namespace. And you also can directly specify the service account names or the identities via this subfield. And the nice thing about a subfield is that it allows you to use prefixes followed by a star, like in the second sub. And that way you can, for example, allow all requests from all namespaces from all service accounts from a namespace. And just third section are the filters, and they are optional, and they allow you to even shrink it more down which events are allowed. For example, that way you can restrict that only certain event types are allowed to be sent to your resource. Okay, let's check out a quick example how this looks like. Imagine we have namespace 1 having ping source 1 and namespace 2 having ping source 2 and a broker. And this broker is protected by an event policy. And in the event policy, we define that only ping source 1 from namespace 1 is allowed to send events to, obviously meaning that ping source 2 is not allowed to send events to the broker. Now you might wonder what happens if you don't have defined any event policy for some resources. For that case, we define some fallback mechanisms or some default authorization modes, which jump in case no event policy is in place for a resource. So, and there we have 3 different options you can choose from. First, allow all, which means that all requests are allowed if no event policy is in place. Deny all, meaning that all requests are denied by default, which kind of forces the user to create an event policy and assign it to the resource. And the third option is the allow same namespace option, which means that only requests from the same namespace as where the resource lives in is allowed to be sent. And as this is default, this could be seen as some breaking change. But as you can simply update or set the default authorization mode, you will be fine. Okay, so going back to the previous example where we had two namespaces and a broker. In this example, we don't have an event policy, which would mean the broker would fall back to the default authorization mode, which is the allow same namespace policy, which would then mean that only requests from the same namespace would be allowed to the broker. In this case, this is only the case for ping source 2. And as ping source 1 is in another namespace as the broker, it would be declined. And by declined, I mean they would receive a 4 or 3 status code. Okay, that's it for security. Now let's check what we have, or which kind of news we have on the integration side. Previously, we had only, or Knative Eventing was kind of limited to a small number of built-in event sources and sinks. For example, we had the API server source or the ping source. And when users wanted to connect to third-party services, they needed to create, for example, or to leverage the container source or write their own source. And of course, this is some burden and maintenance work. Of course, you could also use some third-party sources, but some of them are not maintained very well anymore or even got shut down. But maybe you know the Apache Camel project, and the Apache Camel project, they have the Camlets, which run on Kubernetes and provide you some connectors to various third-party services, for example, service to AWS or to Google Cloud Services or message services or JMS brokers. And so we thought, okay, it would be nice to have support for connecting to third-party services natively in Knative Eventing core. And this is done now by the new so-called integration source and integration sink. And those two new sources, or those new sources and sink allow you now to get events and send events from AWS S3, SQS, SNS, or DynamoDB streams. And it's now super easy for you. For example, if you want to receive events from AWS SQS, you simply create an integration source, add the SQS configuration options, the auth secret, specify the sink as you usually do for a source, and you're done. Afterwards, your sink, in this case the broker, will receive the events from SQS. Similar, if you want to send events back to SQS, you simply create an integration sink, specify the AWS SQS configuration options, the auth secret, and you're done. The sink will create an status where you can send events to, and that's it. And by having this natively in Knative Eventing, you also get this in the usual release cycles, and also it supports, for example, integrating into existing systems what we have so that, for example, it comes with TLS support out of the box. Okay, that's it for eventing integration. So, handing over to Pierangelo.
Event discovery. So the first part is like understanding why we're talking about event discovery. And so as we saw, like when we're building event-driven systems, usually we connect to all sorts of systems that are like either public cloud services or like private internal system services. And the idea is that to know how to consume them, we need to have either good documentations in a way that every field is like documented and well known, or we have like schemas as well. And so far, like what we had like on the documentation website, you had like a long list, and you had to dig through each individual source to understand what was producing, what are the kinds of events I'm going to be able to consume with that source, and what's also the shape of that event in a way that I can, deserialize it and do something useful with it. And yeah, that's the idea. So what do I do next when I visit the documentation is not very helpful? Usually these days, we go to ChatGPT or Claude or whatever you like. We ask it, for example, in this case, I'm asking like, what is the types of event I can consume from AWS DynamoDB streams? It's kind of very lengthy at some point. It's kind of being useful. And it gives me kind of an example shape. So maybe we don't need to do anything. Now we have LLMs, we can solve some of these problems. The issue comes when, if we assume that public services, they are well documented, LLMs maybe can help on some of those. Internal systems are not that well documented. We know that, documentation is not first-class citizens in many like legacy or enterprise systems. And so we need some tools for that. And so probably that's basically the other solution that we have currently is basically create the functions for that event, consume it, and log it, and maybe extract the schema of that event in that way. That's pretty much what everybody's doing. So that's why we created this API. It's called Event Type API. This was present for a while in Eventing. We kind of evolved it in a way that you can describe basically a reference to a resource that is emitting that particular type, and also the attributes. And in these attributes, as you can see, you have the name and the value. The value can also be some sort of template. As you can see in the source value, there is a variable ID in there so that you can describe kind of complex. And then there is, we usually, in these attributes list, you can put whatever, but we recommend at least type, source, and data schema, because data schema is also a link to your schema registry that you may have. People use, I don't know, Confluent, or there are like some other open source. It could be also a GitHub repo somewhere on your private. So that's the idea of like having these APIs, like a Kube API natively, we can consume it. And so as usual, you can list it with CLIs, kubectl get, event type, and you get the list. The other issue is that how do we get like these event types created? You either can create them manually, you can type the full YAML, create them in the cluster. And there is also another way of creating them. We create them automatically as you go through the broker. As we saw in the previous slide, in this slide, as they go through the broker, we basically create these APIs for you, so that you can get a head start, let's say. And that's the idea. Like, as the event goes through the broker, we create that CRD event type, that event type CRD for you. There are obviously downsides to do this, and but this is at least a good started experience. You can kind of get it going, at least in development, and then maybe in production you just turn it off, the automatic creation, and use the manual one. Okay, so last year we had also part of this, we presented this at KubeCon NA, so we had also a full demo. If you are like using a Backstage, there is a plugin for Backstage, you can visualize your catalog with this API. It's kind of cool, go watch it. It's called, Even Discovering Kubernetes. It's on YouTube, so there is a demo there. JobSink. JobSink is another feature we have been working on, and the idea is that when you work on like Lambda type of systems or like serverless type of systems, you have a hard limit on how long that processing can take. It can be in the order of minutes, let's say. But there are like lots of workloads where you have this processing and it's going to take a long time to kind of process and complete. And so that's the idea of JobSync, is really to be able to have a request coming in to an event and then do basically offload this long-running processing in the background. So the idea is that I have an event source, so you can use whatever source you're using, and as you can see, so as we discussed earlier, we can this can come from any system. And basically create, when the event comes into JobSink, what we do is basically create a job for you, and the event is going to be mounted on the file system on that path, and so you can read that event as a JSON and then do your processing. And this can basically take as long as you need to. Another thing that I want to talk about is, as part of this, is a pattern. Basically, now we see people use this JobSink also to create like complex workflow that are like event-driven, so very scalable in a way. And the idea is that before shutting down your job, basically completing your job, is to produce a new event, so that that event can also trigger further processing, basically. So to do that, we also reuse some of like existing features. If you're not familiar with sync binding, the idea of sync binding is to inject an address into a resource that looks like a pod. So it could be a deployment, a job, it could be stateful sets, it could be daemon sets, up to you, or even custom resources, is to inject these as an environment variable, inject an address as an environment variable. We call this ksync. And so basically before completing your job, you're just gonna fire a new event, and that event is gonna basically say, I've completed my processing with this event, and so that you can basically further consume that event for more processing. Even transform. So we didn't do like an introduction, but like eventing pretty much is based on cloud events. Cloud events is a CNCF, also is mainly focused on specifications, but also we produce a bunch of SDKs for different languages, so Python, Java, Node, or others. And it's a specification. What it's really trying to do is to standardize how you transport events across different protocols or different formats. In eventing, primarily we support binary HTTP, so it means that it is a compact form, and the attributes of the event are in the headers, and the body of the request is the data payload. And then also there is a structured JSON. This is a little bit less efficient because we need to deserialize the JSON when we need to apply filters. But you can use both of these. Adopting this format is relatively simple. You need to add a bunch of attributes, but it's still something you need to do additional. The idea is that with Event Transform, we want to like bring systems like that are already existing easily into eventing, and so have this kind of more cloud-native processing for event-driven systems. And not only that, we don't want people to write a bunch of code that is just not heavy lifting or like kind of transformation stuff. And that's the idea of Event Transform, maybe kind of declarative transformations of events. So we started with JSON. Obviously, JSON is very popular for like API or similar. And the idea is that we use this JSON expression language to transform events from one JSON to another, pretty much. It's a relatively simple idea, but it's very effective and helps a lot with like less code to maintain for you all. This is an example expression. It looks like JSON, but it's not. As you can see, the value, these are variables. They are not quoted, so that's how you can tell it's not JSON. So here I have an example. In my example, I have a broker and event transform. And in this example, I'm using the broker reply feature. In the broker reply feature, you can basically have a processing of an event and then reply back with a new event. And that event is going to get queued as a normal event. It would be sent by a different source. In this case, the idea is that I want to extract the payment method from the data. and put that as a attribute of the cloud event so that I can filter and maybe have a processing only for like credit card type of payments. And this is what it looks like in YAML. It's like so this is another example on how to use event transform. There is another way of like, instead of replying back with the new event, I'm gonna forward that to a different sink. And that sink can be also any sort of HTTP URL. It could be outside the cluster even. In this case, I'm just shaping the event to be a proper cloud event. And this is what it looks like. You have if you're familiar with Knative, we usually have this spec.sync, and that sync usually is basically the target of the event. So that was the presentation. Hopefully it was useful, and we have some time for questions if you have. Otherwise, we are going to be at the Project Pavilion Kiosk 3A. Feel free to leave also feedback. That's QR code for feedback. Thank you.
Oh, doesn't work anymore? Yeah. Thank you very much for the presentation. Just one question regarding is there going to be support for clients certificate as well with HTTPS encryption? Is it going to be both way or just server side? That's question one. And question two regarding the AWS support for sources. Is there going to be support for IRSA?
So for TLS, we don't have plans for like mutual TLS. So also client, but feel free to open an issue. We just didn't have the ask. For AWS also, there was no ask, but so I don't know. There is no yet plan. Okay. Any more questions?
Yeah.
Oh yeah.
Thank you very much for your presentation. A great talk. I'm working as a platform engineer, and I need to provide Knative Eventing to multiple teams in the organization. And I understand that the broker ingress right now is a kind of shared service in control plane, right? I'm wondering if is there any plan to support multi-tenancy broker ingress, to split broker ingress to another namespace, things like that.
So when multi-tenancy is like every organization kind of defines it differently. The way currently eventing is designed is similar to how you would consume Kube. You have an API server that is shared, and that's also what is implementing the logic behind the broker. The broker is just a logical representation. There is no power running behind the broker, usually at least, in the shared implementations, okay? So that's the idea. It's kind of depending on there are some organizations that say, okay, multi-tenancy for me means a power running in a specific namespace because I'm going to segregate that with network policies, for example. That is not going to work with eventing. But if you combine with the security features that we have with allow same namespace, you're going to have a pretty good solution around at least being secure and segregated. Now, we can talk about the shared data plane that we have. There is no proper, let's say, multi-tenant segregation in a way that one tenant can overload the data plane and it goes down. It's similar to Kube. So there are some solutions. We also have, if some of the native features don't work and you use service mesh, for example, some sort of service mesh, you can also integrate with that. And we have native integration with Istio because that's the most popular we have, but you can also do something interesting in that. It depends on how you want to offer that, but it's possible. We definitely have people using eventing as a shared. There are also CNCF case studies talking about this. Okay.
Thank you for the presentation. For the authorization part, do you support label-based authorization like network policies? For example, can we accept only from the same namespace but from some senders with label A or label B? Do you see what I mean?
Yeah. So we don't have that. When you say label A and label B, label on what?
In the sender.
Sender being an event source.
Yes.
So no, there is none that, because the way it works is basically we create service accounts, Kubernetes service accounts, and they live in a specific namespace. So there is no labeling. Also because everybody can kind of add labels to those. So it's kind of, I'm not sure like what exactly that entails in terms of like the threat model, you know, of the system. Yeah.
Okay. Thank you.
Any more questions? All right. Thank you so much.